In order for a muscular contraction to occur, an action potential must be introduced at a neuromuscular junction along the sarcolemma of the skeletal muscle. The somatic motor neuron will release neurotransmitters into the synapse at a receptor site, where they are then absorbed by the sarcolemma membrane of the muscle fiber. The neurotransmitters stimulate the sodium channels to open, causing sodium ions to rush into the neuron. This creates a reversal of charge, thus creating an action potential. The action potential travels along the sarcolemma membrane to the T-tubule, where the action potential is brought near to the sarcoplasmic reticulum. Once the action potential is at a receptor site on the T-tubule, it uses ATP for active transportation to bring calcium ions into the sarcoplasm. In the sarcoplasm, there are long strands of actin myofilament, and attached to the actin are strands of tropomyosin and troponin proteins. The calcium diffuses into the sarcomere, where it binds to the troponin proteins.
Once the calcium binds with the troponin, it causes the tropomyosin to twist and move out of the way. When the tropomyosin moves, it uncovers the binding sites on the actin for the myosin to attach to. Then ATP comes and breaks into ADP and a phosphate group, which allows the myosin heads to create a cross-bridge with the actin and attach, and thus converts to high-energy configuration. The myosin heads perform a power stroke, which pulls the actin to overlap. Once the myosin and actin are attached, the actin will continue to contract and overlap the myosin, which causes the muscle to contract and look shorter. When the muscle is done contracting, ATP is needed again to break the cross-bridge between the myosin and actin. ATP converts to ADP and a phosphate group again, and the myosin heads change from high-energy configuration to low-energy configuration and detach. Therefore, the muscle is relaxed again.
Once you are deceased, there is no more AT being produced in the body. However, there is still some left over. Neurotransmitters are still sent from the motor neuron, and action potentials still send a message to the sarcoplasmic reticulum. The calcium is released from the sarcoplasmic reticulum. The calcium can still attach to the troponin, which moves and shifts the tropomyosin. This shows the binding sites and allows the myosin to create a cross-bridge. The leftover ATP in the body will allow the myosin to attach to the actin and contract the muscle. But since no more ATP is being produced, there's no more ATP to break the cross-bridge, which leaves the muscle contracting and never relaxing. This is why, during rigor mortis, our muscles stiffen and stay rigid.